Okay. So, okay. Now we have seen that solution set of this, right, is a vector space, and solution space is a vector space of dimension n minus rank of A, right? What about non-homogeneous equations? Now let's consider a non-homogeneous system. AX equals B. Okay. Again, A is an n by n matrix. X is the set of the vector of unknowns. So A is n by n. X is just x dot up to x and B is B1 to Bm. Okay. The observation is the following observation. Let's pick any solution of this equation. Let x0, which is the Kn, be a solution to Ax equals B. Right? So when you got x0 here, you obtain B, a solution. Now, if x or x1, let's say, is any other solution to Ax equals B, then we have what? Ax1, which is equal to B, but it is also Ax0, right? Both x0 and x1 are solutions to this equation. Ax equals B. Well, from this, we see the following. Ax1 minus Ax0 is just B minus B, which is 0. And from this, we see that x1 minus x0 is equal to 0. Therefore, and x1 minus x0 is the kernel of A, right? Or kernel of A hex, which is just a solution set of solution vector space solution set of Ax equals 0. Evet. Yani bu ne demek? Ax eşittir B'nin iki çözümü varsa iki çözümün farkı homojen sistemin çözümü. Dolayısıyla da kernel'ın içinde conversely yani şunu biliyoruz. So x1 minus x2 is in the kernel. Let's say kernel something like this, point some C in the kernel of A. From this, we of course see the following. X1 is just this fixed solution times C. Yani ne demek bu? AX eşittir B'nin iki çözümü varsa bu iki çözümün farkı A'nın kernel'ından bir şey. Tersine A'nın kernel'ından bir şey olursa conversely if C is in the kernel of a head, then and x0 is the solution of x equals b, then we can do the following. Then what is a x0 plus c? Well, this is just ax0 plus axc, but ax0 is just b, and axc is just 0 because it's in the kernel. So this is just 0. Therefore, this is 0. So what we see is that this vector is also a solution of ax plus ax equals b. Hence, x0 plus c, where c is in the kernel of a head, is also a solution of x equals b. So what we have seen is the following. If we have two solutions of the same non-homogeneous equation ax equals b, which are two solutions of ax equals b, which are x1 and x2, then we see that their difference is an element of the kernel. So one solution can be written as the first solution or zeroth solution plus Kc for some Kc in the kernel. And this shows that if x0 is a solution, where was it? Okay. Yeah, x0 is a solution, and if Kc is any element in the kernel, then x0 plus Kc gives me another solution of this non-homogeneous equation. So this tells us what? To solve this equation, actually it is enough to find one solution of the non-homogeneous equation, and then you just add the vectors in the kernel of a head. This way you get all the solutions of the system ax plus b. Okay? So the conclusion is this. Conclusion. The solution set of ax equals b is equal neye eşit? Bu x0 plus kernel of a head. What we mean by that, this is a vector, this is a subspace. What do I mean by this? I mean the following. You just take this vector and add the elements of this vector space. Okay, in the kernel. So this is just a notation. A vector plus a subspace. It means you just consider all the sums of x0 with the vectors in that subspace. So this thing is just the solution space of this, where x0 is a particular solution of an x equals p. So you just find one solution of this equation. It doesn't matter which one, okay? Just find one solution. And then to this vector, add all the vectors in the kernel, okay? So you get this set. This is the solution set of this equation, okay? This set, unlike the solution set of a homogeneous equation, is not a vector space. Because you see, these are vectors like x0 plus something, right? So if you, for example, this set has no zero in it. Why is that? Because if there were a zero here, then a times that vector would be zero, but a times this vector is not zero, it is b. So this is not a vector subspace. Maybe I should write this.
X0 is a particular solution of x equal to b0 or c0.
There is no b0.
X0 should be the solution of x equal to 0.
No, b. So here a remark. This the solution set x0 plus kernel of a head of the equation x equal b is not a vector subspace of Kn unless b is 0. Why is that? Because this set has no zero in it, right? So if this is because for any element here, x0 plus p in x0 plus kernel a head times x0 plus c is what? This is b. But if b is not 0, this implies this gadget cannot be the 0 vector, right? So this means what? No element here is the 0 vector. Well, it cannot be a subspace because any subspace should contain the 0 vector. Okay, and this doesn't have a 0 vector. In other words, this subspace doesn't have a 0. Doesn't contain the 0 vector. The situation is like this, actually. So, if I am given this equation, I may consider the homogeneous equation. The solution to this, so let's say this is Kn. Solution to this is a subspace. Let's say this subspace. So subspace should pass through the zero. Okay. So this is kernel of a head. So the solution space, subspace of a x equals 0. What about this one? It is just this subspace plus a vector. So you just take this subspace and add to this vector some vector. It is subspace some vector. Let's say x0 is this vector. You just shift this subspace with this vector x0. So you get something like this, right? As another object, it is like a subspace, but it is not. It is just a set. Because it doesn't go through the origin, therefore it is not a subspace. So this is the solution set. I am not saying solution space because it is not a vector space, okay? It is not a solution space, it's a solution set of a x equals b. Okay, of course, in the case b is not zero. So it is just this subspace shifted via this vector. And our proof showed the following. You may use a different x0, not this x0. You may choose some other solution, right? Some other solution, let's say x1. So you may get another vector. That vector will be something like this. Okay. So then x0 plus kernel of a head is the same as x1 plus kernel of a head. So if you choose a different particular solution, again the solution set remains the same. So you may get a different representatives, but the solution set, which is this set, is the same. Okay, but you may of course pick different representatives, different particular solutions. So particular solution is not unique. Any solution to this equation is a particular solution. I may find this one, you may choose this one. Somebody else may choose this one. But the solution set of this system is this, we say affine space. It is not a subspace, but it's a affine space. What do we mean by affine space? You have a subspace and you add a vector to all the vectors in that subspace. You get a parallel copy of your subspace, which we call a affine space. Yani bu bir subspace, bu subspace değil, ama buna afin uzay diyoruz in Turkish. Orijinden geçmiyor ama sizin vektör uzayınızın aslında bir kopyası gibi. Tamam mı?
Belirleyici değerler artış oluşturuyoruz.
Nasıl?
Farklı belirleyici için verdiğimiz değerleri falan yani farklı olarak farklı space'e duruyor. Onlar da farklı işlemlerden çıkıyor. Yani space'in tamamlamış.
X'leri değiştirirsen mi diyorsun?
Evet. B'leri.
B'leri değiştirirsen. Evet. So, you are saying that if I choose here different B's, you get just, of course, yeah, parallel copies of this, right? Each, so if you change this, let's say B prime, you get another system, but the homogeneous system is the same. Therefore, you get this subspace, and then it will be just a shift of this subspace. So you get something like this. It will be again a parallel copy of this one. Yes. Let's do one example. Okay. So the system. Okay. Let's say 2x1 minus x2 plus 3x3 minus x4 equals 1. And then, okay. Şunu şöyle yapayım ya. Fazla zorlanmıyorum. Okay. 2x1 plus x3 x2 minus x3 plus 2x4 equals 2. All right. Hadi şöyle olsun. X1 artı X4 eşittir 0. Okay. So A, right? A is this matrix. It's a 3 by 4 matrix. 1, minus 2, 3, and minus 1. 2, 1, minus 1, 2. 1, 0, 0, 1. X is just x1, x2, x3, and x4. And B is just 1, 2, and 0. Okay. We use again Gaussian elimination, of course. So let's see. 1 eksi 2 3 eksi 2 1 eksi 1 2 efendim 1 0 0 1. Burada da 1 2 0. Okay. Efendim? Şimdi, tamam. 2 ile çarpıp eksi 2 ile çarpıp toplayalım. Yani ikinci satır eksi 2 tane birinci satır. Şu kaldı. Evet. 1 eksi 2 ile çarpıp topluyorum. 0, 5, eksi 7, eksi 2 ile çarpıp 4, eksi 2 ile çarpıp burası 0 oldu. Eksi 1 ile çarpıp topluyorum. 0, 2, eksi 3, 2. Evet, burası da eksi 1. Okay. Şunu 5'e bölüp 1 yapabilirim. Bunu 2'ye bölüp 1 yapabilirim ama şöyle bir üç kağıt yapalım. Daha hani şey gözüksün. Bunu eksi 2 ile çarpıp buraya takayım. So let me just multiply this by -2 and add to this one. So second row is replaced by second row plus -2 times the third row. Buraya dokunayım. Eksi 2 ile çarpıp toplarsam 1, eksi 2 ile çarpıp topladım, eksi 1 değil mi? Eksi 2 ile çarpıp topladım, 0, eksi 2 ile çarpıp topladım, 2. Burası da 0, 2, eksi 3, 2, eksi 1. Okay, now I can kill this guy. So first row is replaced by the third row plus 2 times the second row. So I multiply by 2 and get to this one. 1 and then 0. 2 ile çarpıp topluyorum. 1. 2 ile çarpıp topladım. 2 ile çarpıp topladım. 5. And let's just multiply -2 and the third row is replaced by third row -2 times the second row. 0, 0, eksi 2 ile çarpıp topluyorum. 1, yok, eksi 1, böyle. 2, eksi 2 ile çarpıp topladık, eksi 1. Okay. You see, these operations, you may write down computer algorithms for this, and let the computer, find the row registration of this is done. In applied mathematics, people are using this kind of systems with very large sizes, like 100 by 100 matrices, and then let computer run and find solutions and so on. Of course, there are efficiency problems there, which algorithm uses less time and so on. People are studying those kind of things. That's done in numerical analysis, I guess. But you see, these things can be programmed to a computer, right? Okay. What else can I do? I may now look at the third row, make this +1. So to do so, I have to multiply the third row with -1. So multiply the third row with -1. So we get 1, 0, 1 minus 1, 5, 0, 1, minus 1, 0, 2, 0, 0, 1, minus 2, 5. And then here this guys. Yani şunu öldürmek için ne yapacağım? R1'e R3 çıkartacağım değil mi? Pardon şöyle yapacağım. R1 R1 and this is R2 will go to R2 plus R2. So I just subtract third row from the first one. We get 1, 0, 0. Eksi 1 ile çarpı topluyorum. Artı 2, 1. Burası 0 oldu. Bir de bunu buna ekliyorum. 0, 1, 0 eklediğim için eksi 2 ekliyorum. 7 oldu. And here we have 0, 0, 1, minus 2 and 5. This is the row reduced echelon form, right? I have identity matrix here. It doesn't have to be identity. What you should have, either you have 0 columns or columns containing one non-zero entry, but these non-zero entries also should lie in a row, and all the other entries in that row, well, in this part, they have to be 0, right? Okay, now this is my free variable, right? There's only one free variable. Actually, to see this, we may also consider the following. This is just x1 plus 0x2, 0x3, x4 equals 0. And then I have x2 plus or minus 2x4 equals 7, and x3 minus 2x4 equals 5. So my free variable is only this one. Let's call it S, for example. So if I let x4 equals S, then x1 becomes minus S, x2 becomes 7 plus 2s, and x3 becomes 5 plus 2s, right? So I can write x1, x2, x3, x4 as well. So this is just minus s, 7 plus 2s, 5 plus 3s, and s. And that can be written so that can be written x1, x2, x3, x4, 0, 7, 5, 0 plus s times minus 1, 2, 2, and 1. Okay, and s is any real number. This is just my particular solution. And this is just the s times this vector. This vector is in the kernel of A. Where is it? So my matrix A is this. You see. My matrix A is this. And if you take that vector, -1, 2, 2, 1. If you multiply this, you get 1 -4 eksi 1, eksi 4, eksi 5 artı 6, eksi 1. Efendim? Yok. Particular solution öbürü verir. Öbürü de işte 0, 0 verir. Bunu yazdığında 0, 0 verir. So this is the homogeneous. This is my C. Okay. So this is my S times C. Okay. F is the real number. So this thing is just kernel of A hat. Okay. Efendim? Yes, yes. So all the solutions of solution set of AX equals B is just X0 plus kernel of A hat, which is equal to X0 is this vector, or X0 plus S times, I can write like this, C. And what is this? This is just X0 is 0, 7, 5, 0 plus S times -1, 2, 2, 1. This is in the kernel, and this is the particular solution. And all the solutions of this equation are these gadgets. Solution set is kind of one-dimensional, right? Kernel here has dimension 1. This is the basis element of the kernel. It's one-dimensional. The reason is that the rank of this matrix is 3, right? The rank is 3. So the rank of A is 3. So nullity is 4 minus 3, which is 1. So this is one-dimensional, and this is a basis vector. And any solution to this is just one solution plus S times anything in the kernel. Okay, so that's the typical picture for linear systems, non-homogeneous linear systems.
Hocam ben şey de şu B'den dolayı mı düştü falan?
Rankı mı?
Şuradaki B'nin
Yok, rank is determined by A, not by B. Rank is the rank of this linear transformation.
aslında şu B'yi çıkıyor, B'yi çıkıyor. Onun dimension olduğu için.
Yok. Onlar 30 oldu mu? 50 oldu. Gözüm görmüyor da. Okey.